In this video, we're going to take a look at a problem involving the mean value theorem. So here we have this function, this parabola, and it's given by this quadratic equation. And it says we're supposed to find an x in the interval -4, -1 for this particular function that's guaranteed by the mean value theorem. Well, let's remind ourselves what the mean value theorem says. So the mean value theorem says if f is continuous on some interval AB and differentiable on that interval AB, then there is some value C in that interval AB such that the derivative at C is equal to f of b minus f of a over b minus a. So what is this f of b minus f of a over b minus a? Well, let's take a look at this picture. We've got point B, and it has an x value of b and an output of f of b. And then we've got this point A, which has an x value of a and an output of f of a, whatever the value of the function is at that point. All right, so remember, what is this expression going to tell you? What is that expression going to tell you? Got it? That is the slope of the secant line. That is the slope of the secant line right there. Slope of secant line, which is shown in the diagram below. So what the mean value theorem says is there's some value C. There's some value C in this interval that if I find f prime of C, well, what is that? That's the slope of the tangent line at C. The slope of the tangent line at C is equivalent to the slope of the secant line between those 2 points at x equals C. So down here in this picture, we would see that, okay, we've got this secant line. It's got a certain slope, and the tangent, there's some tangent line that has the same slope, so it would be parallel to that secant line at some value of C, right? It's not here because this tangent line would not be parallel to that secant line. It exists for at least one point C. All right, so let's go take a look at this picture. So what we're looking for is some C in the interval -4, -1, where the derivative at C is equivalent to the slope of the secant line, which is here given by line segment PQ. All right, so we just need to find these things. Can we find the slope of line PQ? Well, I think we can. We've got the point P, which is at -4, +2, and we've got the point Q, which is at -1 and +0.5, looks like. And we could plug in -1 up here and make sure that's correct. So the slope of the secant line is going to be y minus y over x minus x. Let's see, what does that give us? 1.5 or 3/2 over -3, which is 3/2 times -1/3, which is -0.5. And that seems to make sense with this picture here. Down 1 over 2. Looks right, doesn't it? Down 1 over 2. Yeah, that looks good. So what the mean value theorem says then is that there's some value C in this interval where the slope of the tangent line is also -1/2. And you can almost kind of visualize where that would be. It looks like maybe right in here somewhere, the slope of the tangent line. I'm going to guess, maybe somewhere a little between -2 and -3, I'm going to guess. All right, but how do we find it exactly? Well, we need to find a formula for the derivative. So let's do that. So the derivative is, let's see, -1x minus 3. 2 times 1/2 is 1. All right, that looks good. So the derivative then evaluated at some point C, we could just write as -c minus 3. And you could keep it as an x if you want. It's not that big of a deal. But so we'll put, we need -c minus 3 to come out to be negative half. That's the derivative evaluated at c. Okay, let's see. This looks pretty straightforward. We get add 3 to both sides. We get 2.5, and then multiply. Hey, it is right between negative 2 and negative 3. All right, so that kind of makes sense with my picture. If I go to negative 2.5 and then go straight up, it's going to be about right there. And it looks like the slope of the tangent line is going to be, or the tangent line is going to be parallel to the secant line at that point. So the x value guaranteed by the mean value theorem is negative 2.5.